In this video, we're going to continue with our discussion on diversification and portfolio theory. And we're going to discuss a little bit about how we can add a risk-free asset to the portfolio. Right. So now we're going to introduce, in addition to the market portfolio that we have discussed so far, a risk-free asset to the portfolio as well. And let's see what implications that has to our overall understanding of the portfolio theory. Right. Now let's assume that we can borrow and lend unlimited amounts at the risk-free rate. Let's also assume that the risk-free rate is 5%, and we note that there is no risk in the risk-free rate. It's called risk-free is because there is no risk. The return is kind of fixed, which would mean zero standard deviation in the risk-free asset. Now assume that we are saying that we can borrow and lend unlimited amounts, right? So practically, if we have money, we can invest that money. If we don't have money, we can borrow that money, right? This is the broad premise of what we are doing in this setup. Now let's see how does this work. Let's again go back to our portfolios, the list of optimal portfolios that was there. And just for argument's sake, let's say we have a portfolio that looks like this. This is not similar to the earlier portfolio that we had, but something that has a certain return and a certain risk. So this is the risk here, right, in the form of standard deviation of the portfolio. Now what we are saying is that basically this point here is a 5% level, which is where the risk-free rate lies. Now I can borrow and lend unlimited amounts at this point. So if I invest in the risk-free portfolio, all of my money that we have, we invest in this portfolio. That's where we're going to be at point A. If we invest the entire amount that we have in the market portfolio, we're possibly going to be somewhere on this line, right? We're going to be on this entire line anywhere. Also note that this is known as the efficient frontier. So this entire line here is what is known as the efficient frontier, because as discussed earlier, there is no point holding a portfolio or a combination of stocks somewhere here. That's because for every given return, for example, if this is the return we are looking at, which is let's say 10%, for the same 10% return, there is another portfolio. If this is a portfolio X, there is another portfolio Y, where sigma of Y is less than sigma of X, and return of Y is the same as return of X. So there is no sense in holding this portfolio. We should always be holding the portfolio Y. Right? That's the broad premise when we look at a portfolio with a certain risk reward characteristic. And hence, you would almost always hold portfolios only on this line, which is known as the efficient frontier. There's no point holding any portfolio inside of this, right? So that's the broad discussion that we have now. Now let's assume that we can raise money or we can invest money. So let's say we have $100 and we invest it in a combination of 50% into risk-free asset and 50% into the portfolio. So basically that investment has to lie somewhere in between this zone. This is where 100% is in the risk-free asset, and this is where 100% is in the portfolio. Now a combination should lie somewhere in between, right? Logically. So what do? We basically take this point where the risk-free asset lies and we just try and draw a tangential line to the portfolio, right? Somewhere like this. Pardon the drawing. The line would look something like this, where this cuts the portfolio somewhere here on the tangential line. This point where the line from the risk-free rate goes and cuts the efficient frontier, this is a tangent, and this point is what is known as the optimal portfolio. Now let's note what happens across this line, right? If I choose to invest, let's say 50% in this portfolio, and let's call this portfolio S, and 50% in risk-free rate, then the return will be exact weighted average of these two returns somewhere here, right? But what will be the risk? What will be the risk in this portfolio? That's something that we have to define. So there are two cases that we will take. One where we have 50% in risk-free asset, 50% in portfolio. The second case is where we have more than 100% in the portfolio. Can we do that? So if we have invested 100 rupees in risk-free asset and 100 rupees in the portfolio, what's going to be the return? And how does it work if we have, let's say, 100 rupees that we borrow and we invest 200 rupees in the portfolio, right? Let's first look at the case of what is going to be the return. Just as we go ahead, it's important for us to know that this line which is being drawn here, which is the tangential line to the portfolio or efficient frontier, is known as the capital market line, right? It's a ratio between, it's a line that shows the relationship between return versus standard deviation of the portfolio, right? Now when you look at this line in detail, and let's take a couple of cases. Let's assume that we invest 50% of our money in the market portfolio and 50% in the risk-free asset. The return would be a weighted average return. So 0.5 into return on the market portfolio, let's say 12%, and 0.5 into risk-free assets, which is 5%. So we get an average of these two, which is going to be 8.5%. Portfolio standard deviation, portfolio risk. Note, what is the portfolio risk? Portfolio risk is weight of 1 square, sigma of 1 square, plus weight of 2 square, sigma of 2 square, plus 2 weight of 1, weight of 2, sigma of 1, sigma of 2, rho 1, 2. That's what we had discussed earlier as the formula. Now, just that in this formula, sigma 2, which is equal to sigma of the risk-free rate, is equals to 0. So what two terms become 0 here? So this entire term and this entire term both become 0. So this is the portfolio variance, remember, and consequently the portfolio risk will become nothing but W1 sigma 1, which is the weight of the amount that you have invested in the market portfolio and the standard deviation of the market portfolio. That's W1 sigma 1, whatever that is, right? So effectively the risk has become just a proportionate portion because the sigma 2, which is sigma RF, is 0. So both this term and this term become 0 in the equation, right? Now let's flip this a little bit and try and make this more interesting, which is, let's assume that now we borrow, let's say 100 rupees in risk-free rate, and let's say we had 100 rupees of our own. So 100 is own money, 100 is borrowed money, right? So what is the total now that we have? We have a total of 200, right? So now whatever money we had, we are investing twice of that. So W1 is now 200%, correct? And W2 is minus 100%. So we have basically borrowed that entire amount that that we were earlier investing, which we were dividing to the risk-free asset. We have basically borrowed that entire amount. And how would the return come out? Now, because the weight is negative, the return becomes, we have to pay interest on whatever we have borrowed. So that becomes a negative term here. And because we have borrowed this money and invested into the market portfolio, we have twice the amount of portfolio invested now. So we have 2 times the portfolio invested, and now the return will become So the return will become 2 into 12% minus 1 into 5%. So that becomes 19%. We have increased our return by using our ability to borrow money in the risk-free asset, right? So we have borrowed money from the risk-free asset and invested that money in the market portfolio. What happens to the standard deviation? Once again, this will become W1 sigma 1. Weight 1 is 2 into sigma 1, whatever that sigma 1 is. Let's say sigma 1, if you look at our screen, if we say this is the portfolio here, then sigma 1 may be somewhere here. Let's call this at around 11% or something. So if sigma 1 is 11%, we're going to multiply this and that's going to become 22%. So note that by borrowing in risk-free asset, you have increased both risk and return. Now that's a remarkable property of this entire discussion, that logically it does not make sense for anyone to own any kind of portfolio inside this efficient frontier. You should always be on the efficient frontier. Given that you can borrow in risk-free asset and lend in risk-free asset, if you draw a line starting from the risk-free asset that is tangent to the efficient frontier, the point of interaction is what is known as the optimal portfolio. Note that this is the market portfolio and this could have a combination of the stocks in a various weights, but this is the portfolio that essentially gives you the best risk reward ratio, and we'll understand what is the best risk reward ratio. Now this is where you are lending money. When you are lending money, you're effectively investing money. This portion is where you are borrowing money. When you're borrowing money, you take that money and invest. So obviously when you borrow and invest, your return becomes higher. When you lend or you invest into the risk-free asset, your return becomes a weighted average of whatever you have put in. Similarly, the risk increases and in this case the risk decreases. This tangential line is what is called as the capital market line, or CML. This is a relationship between the portfolio return and portfolio standard deviation, right? That is what we mean by the optimal portfolio. Now note that the characteristic of the optimal portfolio, which is the portfolio return minus the risk-free rate, right? At this tangential point, RP minus RF will be the highest for a given sigma, right? And this proportion, this ratio, is what is commonly known as the Sharpe ratio. So what is the importance of the tangency portfolio? The tangency portfolio has the highest expected return for a given level of risk. Therefore, it has the highest value of portfolio return minus risk-free rate, right? That's called the risk premium. This value is known as the Sharpe ratio. How do you get Sharpe ratio? You take the portfolio return and you subtract the risk-free rate from that and divide that by the sigma of the portfolio. What does this mean now? This means that you get risk-free return generally. This is available without taking any risk. Whatever portfolio return you get, for example, let's say you get a portfolio return of 12% minus 5%. You are taking risk only to generate this excess 7% return. 5% was available without any risk. You are taking a risk to take that up to 12, right? When you divide it by the sigma, what you're saying is return, or in other words, excess return generated per unit of risk. Now, this is a very common method that is used to evaluate multiple portfolios. If you have portfolio 1 that has a Sharpe ratio of 1.1 and another one that has a Sharpe ratio of 0.8, you would prefer portfolio 1 because this is generating a bigger excess return per unit of risk, right? So how does it work? Let's say sigma of both the portfolios is 10%. That's the sigma. And we know risk-free rate is, let's say, 5%. Then logically, to get a Sharpe ratio of 1.1, right, you need portfolio return minus risk-free rate by sigma, which means the portfolio return minus risk-free rate should be 11% by 10% to get 1.1, which means the portfolio return has to be 16% in the first case. 16 minus 5, that is 11, divided by 10 is going to give me 1.1. In the second case, the portfolio return has to be 13. 13 minus 5 is 8%. 8% divided by 10 is going to give me 0.8, right? So for the same amount of risk, portfolio 1 is generating a better risk-adjusted return. And that's what is the crux of using Sharpe ratio. What is the idea is that at this optimal portfolio, you have the highest Sharpe ratio, right? For our perspective, what is important is that we kind of outline this entire set now, which is to judge what an investor needs to do. First thing that an investor needs to do is that the best portfolio of common stocks must be selected, right? The market portfolio. Now this could be anywhere on the efficient frontier, but when you draw a tangent line, which is the capital market line, then the tangential portfolio is what is the market portfolio or optimal portfolio. Now this portfolio must be blended with borrowing or lending at the risk-free rate, assuming that is allowed, right? If it is allowed, and in order to attain a level of risk that suits the investor's risk profile. We saw two examples. If you have a risk taker as an investor, you would want to borrow RF and invest in portfolio because you can increase the return here. On the other hand, if you have a risk averse investor who does not want to take risk, then you basically lend, or in other words, invest in RF plus portfolio, thereby reducing the risk and also reducing the return, right? That's basically what an investor needs to do, and that's what is the significance of the tangential portfolio and the capital market line, right? That's broadly it. We'll have a couple of quick questions as we end this video. Explain why the standard deviation of the portfolio that includes the market portfolio and the risk-free asset is only the weighted standard deviation of the market portfolio, and what is Sharpe ratio. Thank you.